Greetings to everyone. The topic of our video today pertains to the captivating realm of strange metals, those peculiar materials that toss conventional physics out the window. Physicists at Rice University have harnessed quantum entanglement, unveiling a breakthrough that illuminates these enigmatic substances. Their findings spotlight a surge in electron entanglement at a pivotal quantum critical point, offering clues that might supercharge future energy technologies like high-temperature superconductors. Without further delay, let us delve into our discussion. For ages, physicists have been wrestling with the enigma of strange metals, materials that scoff at the usual laws governing electricity and magnetism, unlike the obedient copper or gold we know so well. Picture electrons in most metals as disciplined marchers in a parade, sticking to the physics playbook. Strange metals, though. They're the rebels, resisting electricity in odd ways and acting downright bizarre when chilled to frosty lows. A brilliant crew at Rice University, spearheaded by Qimiao Si, the Harry C. and Olga K. Weiss, professor of physics and astronomy, has finally pierced this mystery. How? They wielded a nifty tool called quantum Fisher information, QFI for short, borrowed from quantum metrology. This gadget tracks how electrons mingle and tangle under wild conditions, think extreme cold or pressure. Their adventure, splashed across the pages of Nature Communications on March 14, 2025, uncovers a stunning twist. Electrons in these oddball metals get supremely entangled at a quantum critical point. What's that, you ask? It's the dramatic shift where matter flips between states, like a cosmic costume change from magnetic to non-magnetic. Our discoveries unveil a distinct entanglement dance in strange metals, shining a fresh spotlight on their quirky antics. By tapping into quantum information theory, we're peeling back layers of hidden quantum connections, stuff we couldn't glimpse before. To crack this puzzle, the team dove into the Kondo lattice model. Imagine it as a sandbox where tiny magnetic moments tussle with buzzing electrons. At a crucial tipping point, these interactions crank up the intensity, so much that quasi-particles, the usual heroes of electrical tales, simply vanish. Using QFI, they pinned this disappearing act to electron spins, locking into peak entanglement, right at that quantum critical moment. This isn't your average science trick. QFI, typically a star in quantum info and precision measuring, now takes center stage in metal studies. Qimiao Si, VO, merging quantum information science with condensed matter physics. We're blazing a bold new trail in materials research. Here's the kicker. Their math matched real experiments. Inelastic neutron scattering, which is like shooting neutrons to peak at atomic antics, confirmed their hunch. It aligned perfectly with data from heavy fermion metals like those in the cerium or ytterbium family. This harmony screams quantum entanglement isn't just a cameo. It's a lead player in strange metal behavior. Why should you care? Understanding strange metals isn't merely a nerdy quest, it's a game changer. These materials cozy up to high-temperature superconductors. Think cuprates that superconduct above minus 195.8 degrees Celsius, liquid nitrogen's boiling point. Such champs could ferry electricity without a drop of waste, revamping power grids or powering maglev trains that glide on magnetic cushions. Efficient energy transmission? Yes, please. But wait, there's more. This study flexes quantum info tools on other exotic stuff too. Strange metals might juice up quantum tech, where entanglement is gold. Picture quantum computers crunching problems at warp speed, all thanks to these insights. Shout out to the stellar squad. Yuan Fang, Yiming Wang, Monique Mahankali, and Lei Chen from Rice. Hao Yu Hu from the Donostia International Physics Center, and Silke Paschen from Vienna University of Technology. Their work, fueled by the National Science Foundation, Air Force Office of Scientific Research, Robert A. Welch Foundation, and Vannevar Bush Faculty Fellowship, proves teamwork makes the dream work. The mysteries of strange metals are unraveling, folks. With entanglement lighting the way, who knows what tech marvels await? Stay curious, more quantum wonders are coming your way.
For broader awareness, kindly hit the like, share and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.